So, in order to understand how we can get a total number of options, let's take an example where let's say that you're getting up in the morning and you want to decide what kind of outfit you want to wear. And let's say that you have 2 pairs of pants and 3 shirts. And feel free to fill in those slots with options more appropriate to your wardrobe. The basic stuff that I would wear, but I'd hope that many of you have better fashion sense than I do, or at least more varied. In any case, we live in Florida, so presumably you are going to be wearing 1 pair of pants and 1 shirt. You're not going to layer, and you're not a nudist. I'm thinking if you guys are nudists. If you are, you don't come to class that way. I wouldn't judge, but it doesn't really fit my example, so I'm going to assume you're not. Anyway, if you wanted to find the number of options, you could use something like a tree diagram here to think about it, where you can split it off in terms of the pants, where for 1 pair of pants, you have 3 shirts that you can wear with it, and you have those same 3 shirts for the other pair of pants, so you have a total of 6 ways you can make the outfit. It's kind of like that blood type thing, where we had positive or negative and then 4 blood types to stack onto it for 8 options. Here we have pants or other pants and 3 shirts to stack on there for 6 options. And the pattern here is hinting at what's called the fundamental counting principle, where if we have 2 selections with n of one and m of the other, we just multiply them together to get the total number of options. And hopefully that's somewhat of an intuitive idea, because we've used it a couple times already. But this construction actually generalizes to much larger cases, where if you want to talk about pants and shirts and shoes on top of that, you could go even further and then multiply your options again to get even more of them. But what we're seeing here is a hint at a construction that we'll get to later on, called permutations as well as combinations. For now, though, we're just going to focus on the simpler, as it were, cases with some examples. So, first things first, we have that the access code for a car security system consists of 4 digits, where each digit can be any number 0 through 9, and we want to determine how many ways a code can be generated if A, we're allowed to have repeats, B, repeats are not allowed, or, we have repeats, but the first digit cannot be 1 or 0, I got ahead of myself, or C, each digit must be unique. So for our first case, where we have anything that we want, we can do whatever we have. If we want to find the total number, we can apply the fundamental counting principle, which says we just take the product of each case. Well, if we have repeats and no other conditions, we get 10 options in the first case, 10 options in the second case, 10 options in the third case, and 10 options in the fourth case, which we can condense down using exponential notation to write that as 10 to the 4th power, for a total of 10,000 total combinations. For the second case, if we have repeats but no 0 or 1 in first, well, it's essentially the same thing, except here our total will have 8 options in the first case, then 10 in the second, third, and fourth. If you want to condense that, you could write it as 8 times 10 to the third, but long and short of it is you'd have 8,000 options. And then finally, in our third case, if we have no repeats, to get our total, we would have to understand here that we have 10 options in the first case. You can use any digit there. But then in the second case, we can use any digit except for the first one we used. We have to pick something new. Well, then we'd have 9 left. And then after we have 9, we'd have 8. And then finally, 7 left for that last one. And we'll see later that there's a specific notation we can use for this in terms of what's called a permutation, where we would write this as 10 permute 4. But that's getting ahead of ourselves. For now, we would just say that the total number of options we have here is 5,040. Where what you should notice is that even for a short code with a fairly high restriction of no repeated values, we still have 5,000 options. And that would take quite some time to break down manually, going case by case. And the fact that this takes a long time to do is actually a very important factor in modern data security. But from here, we're going to get one more example looking at this type of combination idea in the context of a probability.